The Earth is essential for the planetary group. Also, the planetary group is essential for the smooth way. Yet, how does our home world in reality fit into the bigger construction of the universe? Well, truth be told, our cosmic home isn't a maverick either, but in addition an indispensable piece of a much bigger construction that draws innumerable system bunches into its circle with its enormous gravitational shaft. Yet, this is unequivocally where it gets precarious. While stargazers have long expected that our vast home has a place with the Lanok supercluster, an astonishing discovery now suggests that we have been classifying the smooth way completely off base. Rather, the new data recommends that we are, as a matter of fact, subject to the impact of a considerably more forcing attractor, one that has the second largest gravitational well in the neighborhood universe and is gradually pulling us closer and closer to itself. Albert Einstein had an unmistakable idea of the hidden designs in the cycles of the universe. After the appearance of quantum mechanics in the 1920s, which couldn't precisely predict where a molecule would be at a given time and whether it would still be a molecule at all, Einstein composed the following lines to his friend and physicist Max Born: "The theory gives a lot, but it doesn't bring us any closer to the secret of the Ancient One, that is, God. Nevertheless, I am convinced that he doesn't play dice." The creator of the theory of relativity was, therefore, persuaded until his death in 1955 that the universe functions according to the fixed standard of cause and effect, that it operates by specific laws. Moreover, that the Ancient One essentially leaves nothing to chance. And if we move the standard from the discussion of quantum mechanics to the cosmic scene, we perceive that the heavenly dice can indeed stay in their cup. In this case, after all, the worlds and cosmic groups don't move haphazardly and at random through space, but are instead firmly connected to imperceptible flows that are directed by large-scale differences in the density of matter. If you like, the designs of the universe in their conscious star groupings resemble a sort of settled, larger-than-life Russian doll. While the Earth is known to have a place with the planetary group, the nearby planetary group, in turn, has a place with the smooth way. And although our home galaxy, with its diameter of 100,000 light-years and its approximately 200 billion stars, can be described as great, most definitely, we should not fail to remember that in the big picture, it is something like one of endless unique pieces. In fact, the smooth way is an indispensable piece of the supposed local gathering and, therefore, of a world group that is home to around 30 undeniable and 70 known Bantam worlds. The local bunch, in turn, is part of the Virgo supercluster, which contains about 100 to 200 world groups and is itself part of the Lanaka supergroup. And while this huge uberstructure has a diameter of 520 million light-years and contains around 100,000 universes, it also acts as an attractor, very much like the Shapley supergroup or the Sloan Great Wall. So, we're dealing with enormous gravity wells that draw universes and galaxy groups to them over a wide region. Anyway, there are also, in fact, structures in the immeasurability of space that display a totally different characteristic. After all, the universe's poor voids, or the dipole repeller, are better known for pushing the cosmic affiliations from them. But back to the sheer power sinks. For a better outline, the specialists look at their impact with the terrestrial water systems, similarly as the natural territory decides the course of the water. The ebb and flow of space through attractors likewise determines the progressions of inestimable structures. So, will it be so hypothetical? Yet, which attractors have actually extended their gravitational hold on the smooth way in practice? The gravitational megadesigns of the nearby universe? Well, that is exactly the question. And really, we assumed we had long ago found the answer to it. According to a study previously considering 8,000 universes, it was concluded that our cosmic home is clearly situated in the Lanaka supercluster. Yet, as often with cosmic discoveries, these findings are only considered certain until they are scrutinized again. And that is exactly what the scientists around Alien Valid from the University of Marseille and the Leibs Organization for Astronomy in Poem have now finished their cosmic test. The researchers utilized the informational databases of the Grandiose Streams 4 survey, which this time included not just the position and development of 8,000, however, of around 56,000 worlds, with a span of 1 billion light-years. Yet how would you indeed even coordinate such a huge smorgasbord of data into a subordinate setting? Great. The main assignment for the stargazers was to uncover the appropriate movements of the singular systems based on exceptional calculations in light of cosmological boundaries. They then, at that point, looked for fixed designs that gave hints to the area and catchment area of the huge attractors. Thusly, the specialists had the option to decide not just the likelihood of the presence of such an attractor, but also whether a specific point in space was connected to it and where the new data goldmine was multiple times bigger than the former one. There was eventually a far-reaching 3D model that described the flows and large-scale gravitational designs of the nearby universe in a degree of detail that had never been accomplished before. In specific, the limits between the individual ranges of prominence of the attractors could be planned more definitively than any time in recent memory. With everything taken into account, the specialists had the option to identify 17 huge gravitational wells in our galactic neighborhood. Along these lines, one of them stood out from the outset. The Sloan Great Wall, along with its related structures, is the gravitational big player in the local universe, and that is implied clearly with a length of something like 1.37 billion light-years. The tremendous universe wall is none other than the largest known bordering structure in the whole universe. Through the aphorism huge design, huge catchment area, the scope of the Sloan Great Wall, therefore, includes a portion of 1 billion cubic light-years. This implies that its gravitational well is about 2 times as huge as the following biggest attractor, the purported Shapley supercluster. However, the full story also includes the way that the gravitational degree of the two monsters could, at last, be significantly more prominent later on, all within the model. They are limited by the external edge of the data field. In light of this, specialists estimate that, in reality, the gravitational bowls extend significantly farther than on paper. But where does the Milky Way fit into the picture of infinite colossal structures? Well, as mentioned, our home galaxy was previously believed to be part of the Laniakea supercluster, yet the ongoing investigation now hugely challenges this arrangement. Have we misidentified our home galaxy? Since Low and C, agreeing to space experts, the stream related to the Milky Way is heading toward 2 different gravitational wells, and the favored endpoint isn't the Laniakea supercluster as previously accepted, but the Shapley supercluster. This applies to practically 60% of the designs analyzed, though only around 40% are, thus moving towards the Laniakea supercluster. Alternatively, this new finding could now amount to nothing other than that our Milky Way doesn't belong to Laniakea by any stretch of the imagination, but to Shapley. Yet maybe this finally applies not exclusively to the nearby group, but also to different pieces of the Laniakea supercluster, which we have, up until this point, misclassified. But why would that be significant from a galactic point of view? Why does it matter that we may now need to find our vast home somewhere else in space? Well, such a cosmic movement truly does, without a doubt, hold tremendous potential for researchers. After all, the effect of the most recent study may furnish specialists with totally new insights into the gravitational scene of the nearby universe. Specifically, the discoveries show how galaxies and other designs cooperate with one another over time and what factors impact them. Applied to a higher context, this could help researchers to understand the similarly tangled and complex dynamics of the universe and its distribution of matter more definitively than ever before. Whether we will also succeed in understanding the foundation of the inauspicious dark flow more precisely than any other time is another matter entirely. The thing is, we should not neglect, despite the fact that structures like the Sloan Great Wall or the Shapley supercluster with their aspects already test our imagination, it may be the case that significantly more gigantic structures are hiding out there. A couple of years ago, a NASA working group led by Alexander Kashlinsky realized that 1,400 galaxy groups follow an unusually uniform stream that must be caused by a supergravitational attraction. However, since its source evidently lies beyond the discernible universe, we can't express out loud what kind of tractor we are dealing with here. Nevertheless, despite the analysis of his associates, Kashlinsky continues to hold onto the idea that the measurements are not a statistical anomaly. Yet, without hard facts, he, too, can only speculate about the true nature of the dark flow. In this regard, he states, we need more data to see what it is or to narrow it down. The main point we can make with assurance is that somewhere far away, the universe is altogether different from what we see locally. Whether it's an alternate universe or a different space-time continuum, we don't know yet. We do, however, understand the importance of following these clues, and be sure to like and subscribe so you never miss another video from us again. We'll see you soon.